Good morning, everybody. 19 says 402 Database Management System, second year, fourth semester. Unit number 2, transaction. Topic number 7, deadlock. So, deadlocks is an unwanted situation that arises in a shared resources environment where the process indefinitely wait for resource that is held by another process. It is assumed the transaction T1, T0, T1, T2 of a number of transactions. T0 needs the resources of X to complete its task. The resource X is held by T1, and T1 is waiting for resource Y, and T2 held by T2. T2 is waiting for resource Z, and which is held by T0. Thus, all the process waiting for each other to release resource in the situation. None of process can finish the task. The situation is known as deadlock. So this is a example. This is a bridge. The same time, left hand side and right hand side meet the two cars. What happen? If any one car can go backside, another one can transfer to one bridge to other bridge. Otherwise, this type of situation, you can choose alternate ways. The traffic's only in one direction. Each section's bridge can be viewed as a resources. If a deadlock occur, it can be resolved if one car backup permit resource and it are rolled back. Several cars may have to backup if the deadlock can occur. This is called starvation is possible, so that one car can backward. If the car is can backward, you can transfer one bridge to other bridge. Otherwise, sometimes deadlock can occur. So database server cannot store your data in particular table. So this is a deadlock characterization. We have four type of characterizations. One is mutual exclusion, hold and wait, and no permissions, and circular wait. Mutual exclusion means one or more one resources must be held by a process is in a non-shareable exclusive mode. Hold and wait, a process hold a resource while waiting for other resources, and no permissions. There is no only volunteer release of resource. Nobody else can make a process given up resources. The circular wait, process A wait for process B, wait for process C, wait for process A. So this is find the difference. Please, all of you find the difference between two image process. So this is two type of process. One is deadlock prevention, another one deadlock detection. Deadlock prevention, DBMs accurately inspect all operations where transactions are about to execute. The DBMs inspect the operations, analyzes if they can create a deadlock situation. So if it is find that deadlock situation might occur, then the transaction is never allowed to be executed. There are a deadlock prevention scheme that is used timestamp ordering mechanism of transaction in order to predetermine deadlock situations. So two commonly used scheme, why wait and die and wound wait. The first one is non-primitive, second one is primitive process. So when the request resources currently held by Q, the P is allowed to wait only if older than Q. Otherwise, P is rolled back. Wound wait primitive, when a process requests a resource currently held by Q, P is allowed to wait only if the P is younger than Q. Otherwise, the queue is rolled back and releasing its resources, that is P wounds queue. Note the both favors older jobs to avoid starvation, and since older job might have done more than expensive to roll back, unnecessary rollback may occur. Two type of schemes, wait and die scheme and wound wait and scheme. The wait and die is the scheme is if transaction request to lock lock a resource data item which already is with conflict locked by other transaction, and transaction one of the two possibility of may occur. If the T is less than Tij, the Ti when request conflict lock is older than Tj, then Ti is allowed to wait until the data item is available. If Ti greater than of Ts Tj, that is Ti is younger than Tj, then Ti tries the Ti is restarted later with a random delay but with the same timestamps. The own wait scheme, if the transaction request to look resources data item which is already held with conflict locked by some other transaction, one of the two possibility may occur. If Ti less than of Ts Tj, then Ti forced to Tj roll back, and the Ti could Tij restarted later with a random delay but with the same timestamp. And if Ti greater than of Tj, then Ti is forced to wait until the resources available. That this scheme this scheme allow the younger transaction to wait, and when the older transaction request item held by younger. For example, suppose I'm going enter into the ATM machine. The first come first is I have complete my work. Second person wait and then can use the process. Otherwise, you take more time to complete of other transaction in your sector. This is wait and die, won't die. This waiting policy, wait the resources, sorry, want the resources, all the resources, it will wait. Same, want the resources, hold the resources, young, and old process is it is die. So want and die policy, want the resources, old process, young process, permit. Want the resource, hold the resources, it will wait. This is a wait and die and versus won't die. So deadlock avoidance, we have using a wait for graph, the simplest method to available track if any deadlock situations may arise. For each transaction entering to the system, node is created when transaction TA requires to log the item, say X, which is held by some other transaction of TJ. Direct edge is created from Ti to Tj. If Tj release the item of X, edge between Ti is dropped and Ti is looked the data item. So we using deadlock avoidance mechanism detect any deadlock situation in advance. This is a wait for lock. System maintain wait for lock graph for every transaction waiting for some data item held by others. The system keep checking if there is any circle in the graph. This wait for locks, wait for locks. Wait for locks X and wait for locks Y. This is one of the example, ATM card with the bank. First user, ATM process, consortium, bank, display main menu. If suppose I'm user, I'm entered into the machine, I insert the card. First, it's verify all details and insert the card, request password, enter the password, verify the account, verify the card with bank. Bank is, if the PIN number is right, okay. If the PIN number wrong, the bad bank account, return the message bank account detail. Print the receipt, reject the card. Request take a card and take a card, display the main screen. This is evaluation process. Filling the blanks, list out the two type of scheme. That's correct. Wait and die scheme and wound wait scheme.